So today we are back with the Star series, and today we are with Vega. Now Vega is pretty fascinating, and what makes it so interesting and important to us and the astronomers is that it is a future North Star, the star which is directly above the North Pole. So it is the only point which is stationary on a rotating sphere, the axis of rotation, and it is above the North Pole. Currently it's Polaris, but in the future it will be replaced by the Vega. It has also occurred in past as far as back in 12,000 BC. Now the traditional name Vega comes from the loose transliteration of the Arabic word waki, which has a meaning of falling or landing. It comes with the phrase the falling eagle. With that, let's look at the location of the Vega in the night sky. Well, it is, since it is the fifth brightest star in the night sky, it's not that hard to find. If you look for the constellation of Lyra, the harp, it's named like that because it looks like harp. Now, it is an important part of a summer triangle, which consists of Vega plus two first magnitude stars, Altair in Aquila, Deneb in Cygnus. Now, it's quite bright and it's often can be seen near the zenith in the mid-northern latitudes during the evening in northern hemisphere summer. From the mid-southern latitudes, it can be seen low above the northern horizon during the southern hemisphere winter. Well, again, since it was a North Star, it should have been pretty important because this is a star which only stays constant throughout the, whole night and the whole season. This change of North Star happened because of the wobble of the Earth as it spins around its axis. Now it's just like a spinning top. Now this wobble happens with a periodicity, just like what happens with a spinning top. And for Earth it's about 25,770 years. In this process, the North Pole ends up changing its position, which was previously pointing towards Polaris, just points towards some other star right now, and currently for the future case it would be Vega. Interestingly, Vega is also the first star ever to be photographed. It was done on 17 July 1850 at the Great Refractor at the Harvard College Observatory. But unfortunately for us, the photograph is yet to be digitalized. The astronomers used the wet plate collidon process to create the daguerreotypes, the type of photographs which you often see in the history textbooks, particularly belonging to the period of 1850s, which are in the midway of the transition from the paintings to the photographs. They kind of look like this. Now since it's a bright star, it must be pretty close to us, and for Earth it's only 25 light years away from us, quite close for a star, and it's also a blue tinged white main sequence star, just like a sun, which is a normal main sequence star. It is fusing hydrogen into helium in its core. Since it's a more massive star, it would have to use more fuel, so it burns fuel more quickly than the smaller ones. So its expected lifetime is actually 1/10 of that of the Sun, and the current age of the star is about 455 million years, or half of what is again expected of a main sequence class A star. It's almost twice as hot as our Sun, and its luminosity is about 40 times greater than the Sun. So since it's occupied by a disk of dust, it may indicate that a planet forming activity may take place around it. So we might expect quite a few of the exoplanets right there. And most of the energy produced in the Vega's core is generated by the carbon-nitrogen-oxygen cycle, or the CNO cycle, which is a type of nuclear process. So in this process, it is often more dominant at temperatures of about 17 million kelvins. Its estimated radius is about 2.5 to 2.7 times the radius of our Sun. But because of its rapid rotation, actually it's more bigger at the equator than at the poles. Its radius at the equator is larger than its radius at the poles, making Vega look more like an egg-shaped star rather than a sphere. And this rapid rotation is so fast. It rotates once in 12.5 hours with a speed of 236 km per second at the equator. Now, that's way fast. And The star will become a red giant in about half a billion years, when it will no longer be able to fuse hydrogen at its core. There are about 8 or more stars near Vega at a distance of 10 light years from it. And the most interesting part about Vega is that its disk of dust is very similar to our solar system's Kuiper belt. And Vega also has the ancient cultural significance, like the constellation Lyra was represented as the vulture or an eagle in Egypt and India. And among the northern Polynesian people, Vega was known as Vetu o Te Tau, the ear star. Eventually, the function became to be denoted by the Pleiades. Now, to the ancient Greeks, the constellation Lyra was formed from the harp of Orpheus, with Vega at its handle. For Roman Empire, the start of the autumn was based upon the hour at which the Vega set below the horizon. And in Hindu mythology, according to P.V. Varthak, Vega is called Abhijit, and it has been mentioned in the Mahabharata. So I think that's enough for this video. I'll see you guys in the next one. Actually, I broke my camera, which I just got fixed a few days ago. Then I don't know whatever happened. It broke again. So until then, I'm going to continue with these faceless videos. So I hope you guys like the video. Stay tuned for the new content. I'll see you guys in the next one. Bye.